Hello, everyone. Thank you for joining us today. On today's webinar on Icinga for Kubernetes, we're excited to have you here. We will kick off in just a moment, but let's just give everyone the chance to actually join the call. Sometimes it just takes a little bit longer. So let's wait for a minute or two, so everyone has the chance to actually join us. In the meantime, you can just give me some thumbs up in the chat, so I have a verification that everyone can actually hear me and probably also see me. And maybe also you could leave a note and tell us where you're from. That would be interesting for us as well. So maybe just an additional side note, you are able to use your microphone, and you can do this, of course. Just make sure that when using your microphone, just use it if you have any questions or actually something to say. Okay, so we have some from Switzerland, many from Germany, Slovenia, Sweden, Switzerland, one more, Czech Republic, Munich, Atlanta, Georgia. Hello, welcome. It's pretty early for you, I guess. Someone from Netherlands and also from the beautiful Montreal in Canada. That's really cool. Thank you for sharing that information to us. Yeah, some time has passed, so let's just get started with today's webinar. One more additional note to every one of you. This webinar is being recorded, and you will get a copy of the recording afterwards. If you do have any questions, you can drop them either in the Q&A section of Microsoft Teams or in the chat, depending on your application that you're using or browser. Either one or the other may be available. So please feel free to drop your questions in either the chat or the Q&A section. We will collect them and we will try to answer as many of them as we can at the end. And with that, I would like to just also show you who we are, what we do, just very quickly. My name is Blarim, and I'm your host of today, kind of a moderator for this session. The actual speaker of today is Eric. He's the CTO of Icinga and also the lead developer behind Icinga for Kubernetes. So it's the perfect person to actually present the stuff that we've been building through the last few months. For those of you who may not know us yet, just very quickly, what is Icinga? Icinga is a powerful monitoring platform used around the world to keep IT infrastructure healthy and also reliable. Through the last decade, Icinga has grown into a modern monitoring solution for very complex environments, whether they are on premises, in the cloud, or across hybrid infrastructure. And now we're extending Icinga to reach to Kubernetes as well. And we're excited to share this with you today. I think Kubernetes monitoring is a very challenging task. As more teams adopt Kubernetes, from our research, they quickly realize that traditional monitoring tools very often struggle to provide meaningful insights into Kubernetes. Kubernetes is very dynamic, it changes constantly, and that basically means that monitoring it isn't just about checking if a container is running or not. From our perspective, you need visibility into services, into workloads, but also the infrastructure beneath it. And ideally, Kubernetes monitoring should not feel like something completely separate from the rest of your stack. As we know, most of the users have a hybrid environment where they mix cloud-native applications with on-premises, with public cloud providers. And yeah, that's why I've been building Icinga for Kubernetes. We wanted to bridge the gap and make Kubernetes monitoring feel like a natural extension of how you already monitor your infrastructure. Our approach brings Kubernetes monitoring into the same workflows, alerting, and visualization tools you already know from Icinga. And the best of it, it works out of the box without needing to reinvent your entire monitoring setup. In today's session, we will show you how to get started, what Icinga for Kubernetes looks like in action, how it can help you simplify and unify your monitoring landscape, and hopefully by the end, you'll know how to install it, how it integrates with your existing Icinga setup, and what kind of visibility it provides to you for monitoring Kubernetes. With that, I would like to hand over to Eric for the actual webinar. Thank you very much for joining us today.
Yeah, all right. Thanks, Baron. I don't know if I have to press a button or something so that my face pops up. Baron, can I just go on, or do you have to?
You can just go on. Yep.
I can just go on. Okay, perfect. So yeah, thanks for the introduction, Blarim, and thanks for the first slides. And I also would say that the amount of participants here shows the interest in Kubernetes and also in how to monitor Kubernetes. We can also see that in our customers and also in our community, so that Kubernetes is a rising topic over the past years. And also our journey in monitoring Kubernetes also started a couple of years ago already, where we had a first proof of concept on how to do it, or rather how to think it, since it showed pretty quickly that we need a whole new idea on how to tackle Kubernetes instead of how we do it with Icinga. And I want to show our journey with a couple of slides so that you get an idea why we do it this way. And then also have a little demo about the just a couple of weeks ago released version, which is version 0.3. So it's still a pretty early idea of how to monitor that stuff. And I also want to say that it's by no means to replace the already heavily used Prometheus and other stuff. So we don't want to go like that. Icinga for Kubernetes is the solution for everybody. We rather think it of a solution for people already using Icinga or having hybrid environments instead of having like full cloud infrastructure. So I'm going to share my slides real quick. And let's go from here, I would say. So I first want to start with how Icinga works at the moment, which is basically like all the other monitoring tools out there, is that we have hosts and services. So really long time ago, it was only physical servers with good old LAMP stacks installed there, where we had a pretty simple host and service setup. After that, we had virtual machines, and now we may have some cloud instances, for example, AWS and Azure and all that stuff. But for Icinga, this is still a host and a service. So a pretty easy and a pretty simple hierarchy. For hosts, it's just an IP, which is reachable or not. And for services, we have different resources which can be monitored, and also all the applications to be monitored, like MySQL, web servers, storages, and all that stuff. So this is pretty basic, and I would refer to that in the next couple of slides to the term traditional monitoring, where we are tied, or we only have the option to define and monitor hosts and service constructs. And around that, of course, we've built tooling. Not only we have like business process and Cube where we can have a little more complexity than hosts and services. We also have dependencies where you can link between hosts and services. But in the end, it's pretty much always the same structure. You need to define a host and you need to define a service and you need to define where that host and where that service is and how to monitor that. And instead of doing this for each and every host and service, you have configuration management and automation in order to speed up the process, in order to streamline configuration, in order to implement monitoring as part of your business processes, in the sense of that if you configure a server, then that it's automatically added to monitoring, or that if you deploy a virtual machine or some other stuff somewhere, then the monitoring is already a part of that. So that, you don't have to define the monitoring configuration after you've deployed that stuff, but with automation and configuration all in one place, that you have it easy. And on top of that, we have a lot of integrations, like for example, metrics writers and all that stuff for writing metrics from check plugins. And that is also a crucial part in the traditional monitoring. So the hosts and services you configure, they are nothing without check plugins, and I will come to that slide later. But we also have, of course, logs where we can look at in order to troubleshoot and debug stuff. Logs can also be used for correlation and analysis of certain failures. And of course, we have metrics, like I already said, metrics generated from check plugins, but not in the sense of compared to Prometheus, where we use metrics as the basis for notifications. That is our check plugins, more in the sense of that you look at the metrics if you have a certain problem, and then you compare timeframes, then you look for anomalies with other services, to have that as a tool to debug and to find problems instead of to actually alert based on that. And the alert actually is generated by check plugins, but the logic, how to get the data and how to interpret the data is implemented into check plugin. So for example, you have like check MySQL, which knows how to connect to a MySQL server and how to gather data from the MySQL server and how to interpret and to correlate the data in order to determine whether the service is okay or critical. So check plugins, in check plugins, there's a common understanding implemented of what is wrong, and there are multiple check plugins out there which are used by each and everyone. There's a collection of check plugins distributed by operating systems so that people don't have to reinvent the wheel. They will just use check plugins which are well known. They have reasonable defaults for thresholds. So for example, with check plugins, you have states, and states tell whether something is good, rather not so good, and really bad. And for that, thresholds are used, and the check plugin will yield a state information and a text saying what is wrong. And it will also, in most cases, provide the metrics for you then after that to have a look at it. And this is a pretty crucial, and this is the heart of traditional monitoring, I would say. So without check plugins, monitoring hosts and services wouldn't be possible, since all the logic, how to monitor and how to interpret the data is done by those check plugins. And this is pretty important, since not each and everyone has to find and configure its own rules how to get data, how to interpret data. You can just use the common understanding of the defaults which are implemented in the check plugins. And now with Kubernetes, things compared to having just hosts and services are a little more complex. So you know that Kubernetes has loads of resource types like nodes, pods, services. You have deployments, then configuration stuff, ingresses. Security is a different topic, networking, storage. So all that stuff, it's a different beast than just having hosts and services. And also to understand how and what to monitor, it requires a deep understanding of the architecture and the components of Kubernetes and all the concepts and tooling around that, so that you know what Kubernetes is doing and that you know what the tools around Kubernetes are doing in order to get all the information you need in order to monitor and understand what's going on behind the scenes. Then there's, of course, because of all the different resource types, you have multiple components and layers to have a look at. So you not only need to understand the Kubernetes architecture, you need to understand the hosts, where the Kubernetes components are running. You need to understand the Kubernetes components, how they interact and all that stuff. So which means that you have a load of failure points. So what could go wrong? And in order to correlate all that information and see if you have a problem, I think you would need the understanding of an entire Kubernetes stack in order to fix all the problems. And the question arises from all that complexity: is it possible to monitor or to put Kubernetes resources into a host and service construct, and then use the well-known check plugins we have in order to monitor it? Spoiler alert, I think not. That's why we do it differently, but we will come to that a couple of slides later. Also, of course, as I said earlier, with traditional monitoring and the configuration, you define what is to monitor. So if you don't configure something, it's not there to monitor. And with Kubernetes, it's a little bit different, since all that stuff in Kubernetes, the resources and pods, can come and go on their own. So the features Kubernetes has, they're pretty cool, like self-healing, auto-scaling, load balancing, and all that stuff. But in the end, that also means that resources can appear and disappear as they wish, I would say. Then you have also features like pod eviction and all that stuff, where pods are rescheduled from one node to another, or if a node fails, then pods are rescheduled. So there's a lot of moving parts in Kubernetes, which are not representable by the static, let's say, static configuration we have for traditional monitoring, since it changes so fast, and also you have to ask yourself which resources to look at and where the entry is for the monitoring. And then Kubernetes, of course, offers a lot of metrics in order to provide information and insights, and that's what Prometheus builds on. But what we see is that, of course, you have all the information available, and you have so many metrics to look at. But you would need to identify on your own which metrics are important to you, and which metrics and which combination you use in order to set up alerting. And companies and people do that on their own. I mean, there are certain online resources, I would say, which collect like golden metrics or rules, which are common to all clusters. But still, there's nothing like where you just install a software and there's a common default or a common sense of defaults implemented. And that's why you would have to build up all the alerts based on the metrics on your own. And then you would have to ask your question: what do I actually want to monitor? Or rather, what do I want to alert based on all the metrics you get from Kubernetes? And now, what is our approach to monitoring Kubernetes with Icinga, or to integrate Kubernetes monitoring into our Icinga interface and into our ecosystem? We thought about multiple approaches, how to do it. So what can come to your mind is that you would install an agent per node, via daemon sets, which collect some information about the health of the nodes there. Then you could have agents per pods in order to gather information about the applications running there. You could also, of course, base your monitoring on metrics like Prometheus does. But what we do is in the first, at least for the first version, is to pull the Kubernetes APIs for information and then listen on events pushed from the Kubernetes APIs. So what we do is we collect all Kubernetes resources, configurations, states, logs, and events, and put that into a database. And whenever a resource changes in Kubernetes, we get an update about that and also reflect that state in our database. And Kubernetes already has a lot of information built in. So basically, when you have a problem, you issue a couple of kubectl commands in order to correlate the information manually to get an idea what is wrong. And our idea is that you don't have to do that you don't have to have the full understanding of all the hierarchy and components of Kubernetes and which kubectl commands to run. We want to collect and correlate that and visualize that accordingly, so that it's easy to get a first overview of how the Kubernetes environment is running and what might be wrong. For that, we have a daemon, which is written in Go and utilizes the libraries, which all the Kubernetes tooling also does. So we are using the Kubernetes libraries there. And the daemon connects to the Kubernetes API, collects all the resources. And what we do is we try to correlate that information and to represent that into an Icinga state, which people already know. So from the check plugins, we have like the understanding of state and text output and certain common defaults for how to evaluate state. And we try to do that as well for the information we collect from the Kubernetes APIs, so that when we think, okay, this information together might be a critical state, we will report that instead of that there's just information of something might be wrong. We try to sum this up and give a state. And all this state is saved into a database, a MySQL database, where a web interface needs access to. The web interface is a module for our Icinga web framework. And we get a lot of benefits from that. So like, for example, permissions and restrictions and authorization, but we see that later. And we could also run this daemon against multiple clusters, so that the database is a central part for all information from all clusters. And you could have the daemon connecting to multiple different clusters, and the web interface as a view layer on top of that, where you can see all the information from all clusters, or if you wish, just from one cluster. Also, monitoring, of course, is nothing without alerting. And if we don't go the host and service route, we did in the past with Icinga, we also lose the possibility to do notifications, and that is built in Icinga 2. So in Icinga 2, you have hosts and services, and based on that, you configure your notifications, and then the Icinga daemon will send the notifications. Now, since we do that differently, and we have a architecture, let's say, which has nothing to do with the core concepts of Icinga, we also have to think about how to send or to do alerting with that architecture. But luckily, we already started a project also quite some time ago, which is called Icinga Notifications, where we have let's say, a separate application which handles notifications. And this application is not meant to be tied to hosts and services as well, but it is like a notification, a daemon which has an API where you can send events and incidents, and the daemon handles the notifications then. And this is also what the Icinga for Kubernetes daemon utilizes in order to send alerts, but I will show that later as well. So we have, let's say the common deploy options for the Kubernetes monitoring. It can run either inside or outside Kubernetes clusters. So if you deploy Icinga for Kubernetes via Helm or as a container, then it recognizes that it's running inside Kubernetes and you don't have to configure anything. If you run a Kubernetes daemon outside of a cluster, you would, of course, need information to which cluster to connect and the authentication and authorization. And it can be installed via packages, or as I said, be run via a container. And now I would say I will show the latest version. And let's see if I can do it like this. Nope, I can't. Okay, can you see that? Okay, that looks good, I would say. Okay, so this is our Icinga web framework, and the Kubernetes module is just a menu entry right here. And if you click on that, you have a little navigation dashboard with all the resources which are collected from the API, where you can click on that. And also what you see here is that we already have a box where we can choose from which cluster to show information. I just chose to show information from all clusters. Here on my machine, I have a Minikube running and a Colima running, which are both Kubernetes development environments. And this is for demo purposes. But you can imagine that if you have more clusters, you can just choose them here or show information from all clusters. And I think it's a good idea to start from deployments in order to show the concept and to understand how we try to simplify the hierarchy from the Kubernetes resources into the web interface. And I will click on that. And what we immediately see is that we have a list view, and it is comparable to all the other modules we have in Icinga, where we have the concept that we start with lists, which are filterable. And if we need detailed information, we just click on an entry, and then we get the detailed information. I would just do that for that failing deployment here. And I will immediately see details, but I would just close that for the moment and go back to the list, since we want to start with that. So this is what we try to do, is that we immediately give an idea of if something is wrong, what is wrong. This example here, of course, is an easy one, since the image is just wrong. But for the demo purposes, it makes sense to just show that, since you can see that we try to immediately show where the problem is. And we also have different view modes, since this is quite verbose, I would say. And if you want to add your information to a dashboard, for example, and then you want that minified, we have that as well. We have a little button here where you can switch between view modes. And if we choose the minimal version, we have a view where we can see all our resources, and we can add that to our dashboard, for example. Let's just do that. And we have a new dashboard of Kubernetes with all deployments. Let's do that. And then we can see that we have our deployments added to a dashboard. So dashboard, of course, entry point of different views. We could have other dashboards in here, like we have for current incidents. Let's go back to our deployments. And what you can see is that the state is saved. So I chose minimal here, and if I switch between views, it remembers that it was minimal and will stay there until I switch back. Then we have, compared to the detail view, we also have a little view where it's not so verbose, but also not minimal, so like in the middle. And what we also try to do is in the footer to reflect certain Kubernetes attributes, for example, read-write deadline seconds, update strategy, and all that stuff. And all the Kubernetes configuration options, you can use them to filter your resources. So if you go to the search bar here at the top and just press space, for example, you can see all the columns available to filter, not only from the deployment itself, but also its relations. For example, a deployment consists of a replica set, so I could filter for the replica set here. And the replica set, of course, has pods, so I can also filter for pods. And what I can also do is filter for labels and annotations and all that stuff. And for our case, it would be interesting to see all deployments which are critical, I think. Let's do that. And now we filtered the list to just those that are not running. And I would go ahead and use that failing deployment to see how we try to help with the hierarchy. If Prometheus is also running, which in most cases is in a Kubernetes cluster, then we also have metrics for the resources. And what we do is, if you go to the detail area, the first thing you always see is a state, metrics, details from the Kubernetes configuration, then labels and annotations, then conditions if there are conditions, and then we have the environment widget where we can see in which part of the hierarchy we are. And now since we clicked on the deployment, we're on top of the hierarchy, and beneath the deployment we have replica sets. This is this start right here, but we also have the children of that deployment also here as a list. And if I click on that replica set here, for example, this is most likely the same view since the deployment actually is a replica set, but it's basically the same. We can scroll down a little bit. Information, as I said, is state, metrics, details. And now if we look at the widget here, we can see that we came from our parent deployment, that we are now on the replica set right here, and that the replica set has children's, those two right here. So you always know where you are in the hierarchy. That's what I want to transport here. And if I go to the pod, so I can narrow down from top to bottom, and also with the environment widget from bottom to top, if that's something I want to do. So if I scroll to that to this pod right here, I can go back to the replica set, for example. And the information gathered is right to the container level, where we would also have logs if the container would produce logs. This one right here, has a problem with the image pulling, so there are no logs. But if I just have a look at Nginx, for example, so let's quickly search for Nginx. This pod right here, we go to the Nginx container. Then we can see that we also have logs. So for example, if there's a failing workload, you could navigate right to the container level if that is necessary in order to have a look at the logs. What we can also do is I go back to the deployments and I would just have a look at labels here so that we do a filter. For example, here we have a label app. Let's quickly filter for that. Let's go for label name. It's app, if I'm not mistaken. And the label value would be, I think it's failing app, right there. And what we did here is reflected in the URL. I hope you can see that. So in the URL, all the filter is mirrored, so there's no state hidden in JavaScript or stuff like that, apart from the view mode here. But all the filters and which resources you look at is here in the URL, which means you can just copy to the URL and give that to someone else, and this person would see the same. And interesting is that you can use the same here in order to restrict certain users to certain resources. So for example, if you have labels or annotations or other structural markup which you use in order to have certain resources which should be shown to certain users or user groups only, you could use the filter you compose here in the filter editor, copy that part and use that as restriction in the authentication authorization part in Icinga. And I would just show that quickly. For example, we will create a new role, which is called Kubernetes. I won't put users in groups here. I would just show it where we have Kubernetes. I have a little much modules. Here it is. And I would just put my filter here. And this filter now applies to all resources. And this user or this user group would now only have access to all resources which have this label with that value. Easy as that. And of course, you could also use, for example, cluster name as a restriction. So it would be cluster name, for example, Minikube and Colima is what I would have to restrict your users to certain clusters only. But this is a feature which we get kind of automatically since we're using a Icinga framework in the back. So let's go back to the deployments, since there's more interesting stuff to show here. For example, Kubernetes has a lot of resources, and often you only care for a certain amount of them. And that's why we added a little feature which is called favorites, and we can add resources we're most interested in to our favorites. We do that for this deployment here. Now let's have a look for a persistent volume claim, for example. Persistent volume claim for me. Let's use this one. Okay, so this is also a good example to show the environment widget again. Like for example here, we're looking at a claim. This one is related to this persistent volume, and this pod here has this claim bound. So we favor this one as well. And now we go to the all favorites. 2 is enough. And now I have those 2 resources added to my favorites, and I can always come back to that view and see or have a look at only those resources which are most important to me. Okay, so what's also interesting maybe is that if we go to the other resources, the information or icons we use here, for example, like duration and strategy here, you can see in the list without the explanation, so that after using the interface for a while, you know for which the icons stand for. This is also the same for the little resource icons we use in our lists. So each resource, of course, has a different icon. We always highlight the different namespace, which can also be used for filtering. And the detail area not only shows those little widgets and detail informations in children's, we also have events related to the resources listed here, but also a global overview of all events right here, for example. So everything what's going on in the clusters reports it here beneath events. And if we go back to the deployment, and this is the same for all resources, we have the configuration as YAML, which was used in order to create the application in the first place. Oh. Right. I don't know if I have forgotten something, but I don't think so. Okay. And I would
There was one request, if you
Yes.
could demonstrate the service view,
Oh, yeah.
the services.
The services view, yes. Services view looks like that. Also the same as we try to do with other resources, I would say. So in the first place, from the services, we try to get the pods which are targeted by that service. We put them in unknown if there are no pods associated with them. So if the label doesn't match any pods, so you can quickly see that. And let's go to Nginx cluster IP, for example. I think it doesn't matter because it's all the same. We see again all the details, all the pods which are part of that, and also not only the pods but also the hierarchy where they're coming from. So, for example, the Nginx pod here is a single pod, and we have a deployment, certain deployments here, and the ports and endpoint list. This one is still a little bit ugly. Yes, we will fix that in newer versions. And this is a thing which I don't like that much, but it gives all the information you need. And the environment widget here also pretty interesting, since from the service you see which ingresses route to that service, and then of course which pods are behind that service, I would say. And yeah. List-wise and environment widget-wise, it's the same for all resources. So the idea repeats from view to view. Are there other requests maybe for the front end? So I will just leave it open. No.
I think we can move on and get back to the questions.
I will stop sharing right now. I think it's done. Is it done? I don't know. I can see my Teams, so I should work. Yeah. What I don't want to wrap up is the following, maybe. So, of course, the idea here, or what we're doing, is pretty basic in the sense of that we use all the information already provided by Kubernetes, and but what we also want to do is that we incorporate, or want to incorporate metrics, and try to build something like people do with check plugins, so that if you install Icinga for Kubernetes, that you have a default set of good monitoring rules, which get you covered from the start, and where you don't have to define each loading rule by hand. And that's what we will try to achieve, of course, with the help of our community and our users, since we would first need to understand and identify the most used metrics and the loading rules and stuff like that. So that is something where you can help, of course. Yep.
Awesome.
That was
Thank
my
you very
final
much.
words.
Perfect. I think we have actually some time left to answer some questions, which is super nice. I'm not sure if we can go through all of them. I will just start by picking those that received the most upvotes. And something that seems to be interesting for many of you is, what about the monitoring footprint on the target Kubernetes cluster?
Yes, a good question, I would say. So what we use there is Kubernetes libraries, and the footprint is low in the sense of that we only get updates which are published anyway in the etcd in the back. The only thing where we put pressure on the Kubernetes cluster is how we get the logs. So the logs are API requests, which we have to do at the moment. So for each container, we do, I don't know, an API request every 5 minutes. So that is this is the pressure we do. All the other stuff is like another connection to the Kubernetes cluster, I would say, which is negligible. But logs might be a problem. So if there are many containers, we would do a lot of API requests. But also this is something we already have in our minds to think about how we can shift that, maybe using Fluentd or some other log shippers and rely on that, for example.
Now, we have seen some metrics in some of those views. And one question is if this is part of the Kubernetes module or if this is using another module like Grafana. I will take the easy ones and leave the more technical questions to Eric. So in this case, we are actually integrating directly with Prometheus. The reason for that is that from our perspective, we believe that the majority of Kubernetes users, they already have a Prometheus running somewhere. Maybe not everyone, but the majority of them. So if you have Prometheus already running, you can just connect it to the Kubernetes module and you're done. It will give you a first insight into the metrics. Of course, not all of them currently CPU and memory, but it gives you a first insight to get an idea about the load of something. So no other modules are required for that. However, Prometheus in this case is required. So Eric, now one for you. How does this integrate, so the Kubernetes module with a distributed Icinga ecosystem where we have hundreds of endpoints?
Hundreds of endpoints in the sense of agents, satellites?
I think so, yeah. Yeah, I think so, yes.
Okay. All right. This is pretty interesting since it's not connected to the Kubernetes architecture at all. So the only thing where the connection is the web interface, and of course the database beneath that. So all Kubernetes daemons, I would say, I would call them like that, would need a connection to the database. So that is what you have to achieve. And if the Kubernetes is lying somewhere network-wise, where it's not allowed to connect to any databases, then we can't reuse the Icinga, let's say, cluster architecture for that. So this is something for later, for real later. So now it's just you have to think of that as a separate Icinga software, which is just designed to integrate Kubernetes into your environment. And it's not related to the Icinga 2 at all. Does it answer the question, or let's see?
I think so. It was provided through the Q&A section, so I'm not sure if we can get feedback on that. I will check it out later, maybe. But the other way around, now Ben is asking, in case that we have many Kubernetes clusters, and each of them is managed by a different team. How would I let each team monitor their environment without having access to the other Kubernetes clusters?
Okay, that would be easy since we provide handshots, and you could deploy a whole Icinga stack into a Kubernetes environment, and then you would have it there. Of course, then if Kubernetes is down or something is wrong, of course, maybe your monitoring is also compromised then. But they would have to then use packages and use a monitoring agent for the cluster, I would say. So they would spin up and install Icinga Web and Icinga Kubernetes, and then they're done. And of course, it's a separate database.
Or use the same collector with multiple clusters and restrict them? Yeah. Would that be an option?
Yes, it would be an option as well, of course, but this would require configuration-wise is this a little more effort, but yeah, also possible. All Kubernetes daemons report into the same database, and you only have one web interface. And then you have users and user groups where you put the restriction I showed in, and you say, okay, this team has access to cluster name, production, New York, whatever. And then they only see the resources from there. But other people could see all resources. So that is that would only be possible with that setup.
Lisa is pointing out that in the documentation, it currently says that it's only possible to monitor one Kubernetes cluster per Icinga for Kubernetes installation. I think that's outdated, right?
Oh,
so either it's in the README or in the docs. We definitely need to update that because, as you have seen, it's now possible to monitor multiple clusters with one Icinga for Kubernetes. Now, maybe one or two more questions before we wrap it up. So let me check that out. How does this work with RUC monitoring and the like? Very quickly answered, it does not. Icinga for Kubernetes is fully integrated into the Icinga web interface and will not work with any alternative web interfaces. Since we're heavily relying on our own libraries, our own views, and all our own framework, basically, for us, this is the only option.
Just a second. Other modules or other could select from the database. So if they, I don't know, the daemon writes on database, they could write their own front end using the database. That would be possible. But yeah. Sorry for the interruption.
So last question for today. Can you say something about notifications in connection with Icinga for Kubernetes? How does this work?
I'm so sorry. I forgot about that completely. Give me a second, okay? I just share my screen again. It's actually pretty easy. I just have to press share. Where is it? I can't share my screen anymore. Second. So can you see my Kubernetes again? I think so.
Yep.
Okay. So it would be as easy as the following. You would need the Icinga notifications and Icinga notifications web. It looks like that. I have not much in it, but in the end, it's a tool like PagerDuty, I would say, which is on premise. I might just show you real quick what you would do. You would create a schedule, for example, for some on-call rotation. In that rotation, in that schedule, you would add some rotations. For example, let's say here 24/7, handoff every week at 9 a.m. So you see no text configuration whatsoever. Just add that. And of course, Blairim has to be on call and myself so that it's fair. And you would see a schedule, and this one could be used as a target for notifications. And I already configured notifications. We go in Kubernetes, it works like that. You go to the notifications tab here, choose your cluster, and then configure the notifications URL and the back URL right here. In my case, it's pretty easy since it's all local. And then it already writes notifications, and it would look like that, for example. Since I have some failing stuff, we could look at FluentD here, for example. We would have an incident reported in the notifications web interface. We can also see that we have that it's from our event source, Icinga for Kubernetes. Other event sources could be Icinga 2 and other clusters, stuff like that. And now this one here, if it would be next week, we would get a mail, either Blairim or I would get a mail, depending on who's on call about that problem. So that's basically it. So the integration here is pretty simple in the sense of that you just have to install Icinga notifications, install Icinga notifications web, all packages are there, and then go to modules, go to Kubernetes, go to notifications, do some stuff here, and then you're done. Yep.
Could you send different notifications per service, per replica set, per daemon, or per resource to different notification groups?
Yes, you can do that. I can't. Wait a moment. I do stop sharing now since you can do that. Since you have event rules there, can't show it since I wanted to show it, but I have a bug because I played around with the notification stuff and I can't get it back to a working state. But you have a event rule editor, I would say, where you can, you saw the filter, we had the filter bar, and you can think of that filter bar in multiple levels and multiple escalation layers. And you could set something up saying, okay, Kubernetes resources matching this attributes should get reported based on this event rules, and other resources based on other attributes get reported by other event rules, which then also means that other people get notified by other channels and stuff like that. So yeah, the notifications is also a pretty, let's say, how to say, a pretty nice module with a lot of features, but only around notifications, of course. So definitely worth to look at that. And since it's the future and Kubernetes will use it and the other Icinga ecosystem will use it, it's also the way to go for other clients maybe to make use of that.
Awesome. All right. So for those of you who are now ready to get started with Kubernetes, you can check out our website. In the docs section, you will find detailed instructions about how Icinga for Kubernetes can be installed. So there are different options. Pick the one that suits you. Give us feedback either on GitHub. So this module is fairly new, but also very promising to us and also for our users. And we of course heavily rely on your feedback as well. Please don't hesitate to send us everything you found out about the module, be it on GitHub, on our forum platform. Hell, maybe you send a carrier pigeon. We don't care. Just share your feedback with us. On another note, so first of all, thank you very much, Eric, and thanks all of you for attending today. It was a pleasure to host this event here. Since this was received very well, we will very likely continue to organize more webinars throughout the next few months. Something that we already know what we're going to do is to have another webinar on Icinga dependencies. On a side note, today we did not only have this webinar, we also had a very major release today of a very new module called Icinga Dependency Views. Stay tuned on our blog post. We will publish very soon more information about that. But the new module will enable you to visualize dependencies that you have configured in Icinga 2, something that exists since day one in Icinga 2, but we lack the visualization of it. This is coming today, and we will have a webinar on that as well very soon. So stay tuned, read our blog post, read our newsletter, subscribe to the newsletter if you don't have it already. And we will hopefully meet in one of our future webinars. For today, I say goodbye and thank you very much for joining us today.